The quadratic formula is used to solve for x. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. We use it when we are solving a polynomial in the form ax squared plus bx plus c equals 0. This is how we can identify the a, the b, and the c in the formula, and it only works if that polynomial is equal to 0. Solve for a. 8a squared plus 6a equals negative 5. When we use the quadratic formula, we have to use it in a polynomial that's set equal to 0. So we need to rewrite this polynomial so that this negative 5 is on the other side. That's going to leave us with the polynomial 8a squared plus 6a plus 5 equals 0. From here I can identify a, b, and c. A is going to be 8, b is 6, c is 5. I'm going to substitute that into my quadratic formula to get negative 6 plus or minus the square root of 6 squared minus 4, 8, 5 times 8 times 5, all divided by 2 times 8. Simplifying, 6 squared is 36, 4 times 8 times 5 is 160, and 2 times 8 is 16. I am going to continue to simplify by doing 36 minus 160. That gives me the square root of negative 124. From here, I can keep going. My negative 124, I can break that apart. Because I have a negative underneath a square root symbol, I can simplify that by breaking off my negative 1 in its own square root and having that being multiplied by the square root of 124. Coming over here to finish my work, I know that the square root of negative 1 is I, so now I have negative 6 plus or minus I times the square root of 124. I want to break 124 apart into its square root factors. I know that 124 is divisible by 4, which is a perfect square. So this is going to become the square root of 4 times 31. I want to do that because I know that the square root of 4 is 2. So I'm going to pull that 2 out front, which now leaves me with negative 6 plus or minus 2i times the square root of 31, all divided by 16. My square root cannot be simplified any further, but the other thing that I can do is looking outside my radical on all 3 of my terms. All 3 of these numbers here are divisible by 2. So this is a fraction that can be reduced. So I'm going to reduce it by taking my negative 6 divided by 2, my 2i divided by 2, and my 16 divided by 2. That's going to leave me with negative 3 plus or minus I square root 31, all divided by 8. My final answer has to be written in a solution set, so that's going to leave me with negative 3 plus I square root 31 divided by 8, and negative 3 minus I square root 31 divided by 8.